Welcome everybody to the Midas Mission Seminar Series for this month. We have Dr. Jeremy Espino, who is the co-PI of the Informatics Services Group of the Midas Network. He is at the Department of Biomedical Informatics at the University of Pittsburgh, and he will be talking today to us about the EpiCaseMap software that his team has been developing as part of the ISG. So thank you, Jeremy, for agreeing to talk, and we look forward to hearing what you have to say.
Thank you, Sean. So as Sean said, I will be showing off EpiCaseMap. What you see on the screen here is on the left is the application, and on the right is the documentation that we have prepared for the application itself. If you want to follow along, here's a small shortened URL you can go to. goo.gl/Q_NFTE will get you to this documentation page if you want to follow along. So let me make that really big so you can read that right there.
Maybe put that URL in the chat, Jeremy.
Okay, hold on a sec.
Oh yeah, okay, I see it there.
But let me, I'll throw open the chat too. Chat, send to everyone. All right, so there's the documentation in the chat window. And this documentation is commentable, so feel free to add your comments. Of course, I will review them. So EpiCaseMap is an application that we developed in conjunction with Los Alamos Group at Midas. And they have requested an application wherein they would be able to plot cases of disease on a map and on a graph alongside other resources that indicated possibly cases of disease. In this case, their example was Twitter data as well as Ebola cases in West Africa. So let me get into the EpiCaseMap application. To log in, you go to this URL, betaweb.rods.edu/EpiCaseMap. There's a login page, and I'll log in using my test account. When you first log into EpiCaseMap, if you're a new user and you haven't ever used it before, you won't have anything to look at. But by default, the EpiCaseMap application will show you all the visualizations that you've prepared. So let me just give you a first example, so a taste of EpiCaseMap. This is the use case that we started off with Los Alamos, wherein they had Twitter mentions of Ebola, and they also had cases of Ebola in West Africa. In this case, we're showing Liberia cases. So as you can see, we have a map that we can easily navigate, as well as a graph on the bottom. And the graph, you're able to zoom in to the details of the graph in certain sections. We can animate this map readily, showing the individual cases of disease on the screen. We can step through individually time by time, time step by time step. We can show the values of any of the individual place marks on the screen. And we're testing out this secondary data function next. So if you want to have additional data about a point, we'll be able to include it as circles. That's a beta function. It's really easy to toggle different data on and off on the screen just by clicking on the individual color swatches on the left. And if you want to zoom into a certain area, like this peak over here, just click and drag, and we'll see the aggregate of events on the map for that area. So this is the basic view. Now, before I get into some of the other details about the map, I'd like to show you the part of EpiCaseMap that is pretty different in terms of most visualization tools you see out there. What we notice is most visualization tools don't really give you the facilities to manage your data. That is, upload your data in different formats, give you wizards so that you can upload the data, and be able to share your data with other users. So this is the other side of EpiCaseMap, which is the data management function. So I'll move in our documentation to the next section, data series management. To manage data in EpiCaseMap, click on Manage. And there are two areas where you can manage the system. The first one is the data series. So I'll click here. So you'll see I have 28 data series loaded into the system already. These are spatial temporal data series. For example, that Twitter data is right over here. Clicking this edit icon will show me the data itself. You notice that for each of the series, you can include a title, but we also include this metadata, which allows you to track the provenance of the data that was uploaded. And these are data fields that are under recommendation by the W3C. So we adopted standards for metadata in this case. It's pretty easy to upload data into the system. So I don't want to mess this particular series. To upload new data into the system, you click on this plus button next to your the title of the data series management page. And you're first presented with a dialog box which asks you, hey, you got to name this data. So I'm going to do a demonstration of data upload using TICO, okay, just to show you something that is pretty complicated, but we made it more easy. So I'll say TICO data upload test. So if you don't know what TICO is a database at the University of Pittsburgh Graduate School of Public Health that contains historical epidemiological data since I think it's late 1800s and such that they collected and put in a database. And has an application programming interface that we're accessing and made it even easier to get data out of that system. So here I've typed in TICO data upload test, and I'll just say that uploading data for this demo. I'll call it version 1. I'll put my name over here. Publisher was TICO. It's existing version, and this is free for use. Once I input my description of my data, I click on Save, and then it gives me the opportunity to load the data. So I can upload the data using several different methods. I can choose a local file, and the file format itself, if you're using a local file, is pretty simple. It basically has 4 columns in comma delimited format: the time, the latitude, longitude, and the value. And that's it. So it's pretty simple. If you have the data online, like this particular file is online at a URL, I could copy that URL here and also upload it. So this is great if you have, let's say, a system that is publishing data online and you don't want to cut and paste, you don't want to save and load, you just provide the URL. We also provide the ability to query TICO directly. So here I'll click on the TICO query wizard, and what I'll do is to select Rocky Mountain spotted fever, and I'll say I want to start from 2006 and end in 2010. I'll build a query for TICO, and it builds the API query up here, and then I'll click on Upload. So now the system is pulling data from the TICO system remotely and basically staged it on our system. So one of the problems that we have with lots of data, with data from external systems and data you might use if you're an epidemiologist, is the lack of standardization in location identifiers. So in this case, we used a resource that we've created called the Apollo Location Service as a system where we can look up locations and map them to the correct locations, that is the locations that we think are present in the data. So for example, in TICO, there is a list of all these unique state names, all right? And EpiCaseMap did its best using the Apollo location service to map, for example, Michigan to Michigan in the United States of America. Okay. For some of these locations, it wasn't really sure, and it's giving me the option to say, can you confirm this? So I'll click on here for Colorado, and it says, okay, well, there was Colorado. There was also Pozo, Colorado. Which one do you want? So I'll click on that one. And I do that for each of these gray locations, confirming what I want. It usually picks up the first one correctly. And just making sure that I've got the right locations. Now here's one that would definitely cause a problem. Georgia. So Georgia, there's Georgia the country, there's Georgia in the United States of America, and in the location service we have South Georgia, all right? So which one is it? Well, here we're talking about TICO data, it's the United States, so I want Georgia, United States of America. I go back to my summary. You can have cases where there's a location, for example, in TICO data, and it just doesn't match with anything. But if we do a secondary query of the location service, we see that, okay, there's a possibility that upstate New York could match with this particular location in our service called State University of New York, Upstate Medical University. So I happen to know where Upstate Medical University is. It's near Syracuse in upstate New York, and I can confirm that this is what I want by clicking on the view location in the location service. And let's see, I'll just zoom out here and just make sure this is in New York. So this is the way we're combining two of our applications, in this case our EpiCaseMap and the Apollo location service, so we can make a pretty nifty system. So that's in New York, it's upstate, and I like that, so I'll keep it the way it is and go back to my summary. So you'll see that it said, okay, you picked upstate New York, just letting you know. I'll accept California. And now that I've got either all blue or orange, sometimes you just can't match a particular location because it doesn't exist in the location service at this point. But we're always adding additional locations into the location service as we go and as needed. Once I have my mapped locations from TICO to standard locations as seen in the location service, I click on Submit. The data is getting processed and then shows me a preview of the data that was loaded. And you'll see that it located each of these locations and indicated the point, the center point of each state and map them appropriately to the values and date ranges. So I'll save this. So now I have my TICO data upload test, and I'm ready to make a visualization. So once you have data uploaded, you create a visualization by going to our visualization management page. Again, click on plus. That allows me to create a new visualization. And you'll see that when you create a visualization, you have the choice, because you are managing your data, of selecting any of the data that's available in the system that you uploaded or someone has shared with you. So some of these data sets were shared with me, and I can choose them and show them on the same screen. So I'll pick my TICO data upload test. I don't know, there's a Fred influenza run here. I'll try that out. And I'll pick, I don't know, just for fun, I'll put Ebola Geo Twitter. And this will be, I'll call this Smorgasbord. Smorgasbord. Board. How do you spell that? Berg. Save and close that. And then I can view this visualization. And similarly to before, it shows me a default view. I see my Ebola Twitter events here. There's a Fred influenza run here over in Allegheny County, and I've got my TICO data not showing up very clearly. Let's see, it's in purple. All right, there's these little dots in the middle of each state. And we can animate this, of course. I can take this subsection here and play it forward. I'll zoom in a little closer so that there's some activity. Let me get closer over here. There we go. So we see the Fred stuff going on. I've got my Twitter on the same page, and I've got some that test data I've uploaded from TICO. So this is an example where you can just combine data series onto a single visualization. Let me go back to one of the other visualizations that I have here to show you what we've done. Showed you the TICO data, some of the bullet Twitter in the beginning. Here's an interesting example. These are Chicago rodents versus a vacant building. So anything that is geolocated with coordinates and has a value, you can upload into the system and visualize and see the relationship between the values. Of course, we can also look at individual numbers. So if I take a look at these green things, these service requests, and zoom in, I can say, okay, well, in this given area, you know, how many particular requests were made in that little dot. Show you another visualization here. So the Informatics Services Group, the Carnegie Mellon subgroup at our services group, create synthetic populations. So they did a custom synthetic population for Canada, and here I'm just showing you that we took the synthetic population household and people data and plotted it in EpiCaseMap so you can see its location in Canada. So it's in Montreal. Then zooming up close, we can see all the way down to the street level the location of these households and people. And then for the people, take a look at how many numbers of people at each location based on the synthetic population. So as I said, it's a way that you can visualize data resources and display them on a map and find the relationships spatially and also temporally. Let me go back to this one of these visualizations here, the Ebola Liberia cases here. There's an extended set of controls in the system. So for example, if I don't like the background, I can make it different colors. So here's a dark background, so I can make things stand out. So go here. On the fly, you can pick different series. So for example, if I want to show this as deaths, and I didn't want to show Twitter more, I can take that out. So on the fly, I can select different series that I've added to my visualization and totally change the colors as I go. I can pick different color schemes as I go and add additional series so I can display more of these series that I've been managing. There's also some additional controls for playback to make it smoother if your machine is slow. And then for very dense data, you can say, okay, I only draw every like 7 days and stuff. Point decay allows you to have some of these points persist over time so that they don't quickly disappear if they're very episodic. So if I make it slower, then I'm able to see more of the activity because they'll stay persistent, like that. And then there are options if you have data where there's gaps in the data. We have options so that you can bridge them, so do some interpolation. And since the system doesn't need a value for even missing values, you can fill them in with zeros. So problematic data allows you to these small features here allow you to interpolate with the data. Okay. Other things in the system in terms of data management are that, in the visualization is I can see the detail of a certain area. So right here, so if I just want to see this, I can zoom into this area and see that area. And then now I get to see what the data actually looks like in terms of values. So you're not restricted to that too. Okay, and at the same time, you can play through that little section also. All right. Other things you can do for any of the data, you can share among users of the system. So that's this button here, Edit Permissions. So there's some test users in the system. I can enable sharing different data with them or visualizations by clicking on these buttons here and then editing the permissions. And it's pretty granular. We can say you can use the data or not use it. You know, that's pretty obvious, but you can read it or not read it so you can see the individual values. Can you edit the data and re-upload, or can you manage and delete things? So it's pretty granular controls. The last thing that I wanted to preview here and show you is that the entire system itself is open for other people to integrate with. So sticking to the Informatics Services Group philosophy of creating systems that are open and accessible and integratable, we've created a web service in the form of a web-based API. This is our online documentation for the EpiCaseMap API. So for example, for my visualizations, I can do a HTTP request via GET and say, okay, show me all my visualizations in a JSON format. So I have them all here. Or get me the data that I uploaded as a series based on an ID. So I can get all the series data from the stuff that I uploaded. So this is a way that this system is really not closed, and you can integrate with other applications if you've already uploaded data into EpiCaseMap and using it to manage both your data series as well as your visualizations. Coming soon is something that I know people are very interested. Right now, the visualizations comprise point-based place marks, and we're working on a chloropleth version. This was instructed from the people who worked at during the hackathon, and we saw some of the different techniques that they used and are adapting them into the EpiCaseMap system so that the visualization tools are more complete. So at this point, I'll take any questions that you may have. Be happy to entertain them.
Great, thanks, Jeremy. Are there any questions from the audience? So Jeremy, I have a question / suggestion as I was watching you use the tool. I thought it was really nice, the feature about doing the searches for locations and being able to then resolve the locations.
Yeah.
So one thing that occurred to me, if I do that, so I may have a very large data set with lots of locations that I've implemented, and if I want to resolve those in that interface, I mean, it might be a little tedious, but two, does it save? It would be good to be able to save that work for future use, for future visualizations. So first question is, would it be useful to have, like, say, I think I'm lucky feature, which would say take the first option of all of those just to see what I get?
Yeah, we could do something like that, like in terms of how well how well the search was carried out, like all the keywords are found, and so that's the best one for like that.
Yeah.
Yeah. Right now, what it does, those particular mappings that were in blue because there was only one result, and all the keywords matched in that case. So it does do a little bit. It does try to help you in that way. And then where it doesn't resolve to those conditions, it gives you the option of looking. But in just looking at that feature, I mean, I think that this might be one of the more killer features that we put into this application that is reusable across many different projects, is mapping to locations using the location service.
Yeah, so the follow-on would be, I mean, it would be really cool that as I'm resolving those, and on top of that, if I have ones that are not currently listed in the, I mean, like with TICO, you're going to have lots of historic places that aren't necessarily listed in your Apollo location services. I mean, probably eventually they would be, so to add sort of a crowdsourcing component to it, can you, number one, save, like if I choose a location with a name, does that information get saved like you did with Syracuse and upstate New York for future use, and or can I create new Apollo location elements through the Apollo location services when I have something that's not currently listed, like Sean Brown's backyard cemetery or something.
Right.
Terribly.
So from the perspective of saving the mapping so that they can be reused, we don't allow reuse of the mappings yet, but I think that's a really good idea. So we can create a list of existing mappings and say, like, hey, instead of manually going through this, someone has already done this for this particular data set. Do you want to apply it? It would basically give you a list of all blue mappings, and you could, of course, still review them if you wanted to. So I think that's a good idea. And then in the case where you have a location that does not exist in the location service, the location service itself has facilities for creating new locations by drawing borders of that location and saving them. You just have to name it appropriately so that map occurs. So I think that would be possible. You'd open up another window when that happened in the location service, and then create it with that name that you're trying to resolve. But I think those are good ideas, Sean.
Okay, great, thanks.
You're welcome.
Is there any other questions from the audience? Okay, if there are no other questions from the audience, Jeremy, thank you very much for a very nice presentation. We will be posting this on the YouTube channel as a video for those that couldn't make it and for those that want to refer back to it. And again, thank you for presenting a really nice tool you guys have been developing. It's really cool to see how this has evolved and come along. It's really getting to a place where it can do some real killer work. So great job, Jeremy, to you and your team. Thanks.
Yeah, I want to thank my team, Terry, Sahawat, and Amin, who worked very well in creating this application. Thank you, Sean.
Thanks.